want to find where the function is concave up and concave down. So remember, that is always going to involve our second derivative and setting it equal to 0 or does not exist. And when we take our second derivative, we always want to have it as one fraction that will then set the numerator and denominator equal to 0. Once we get those numbers, we then draw our number line with f double prime. So with this function, I will take the first derivative, and that will give us 12x to the third, and then minus 36x. Now, because we're interested in concave up, concave down, we're looking at the second derivative. So when I take the second derivative, I have 12 times 3, so 36x squared minus, and then just 36, because our x to the first is a linear term. So we will set this equal to 0, because with concave up, concave down, it is about the second derivative. And again, once we get the second derivative, we really could care less about what the first derivative is. It's all of our work is about this second derivative being equal to 0 and drawing a number line with the second derivative. Now, to solve this equation, the first thing I would notice is that you have an x squared. That is your highest power. And because that is your highest power, there's different ways of going about it, but you could isolate it to get x squared is equal to a number. So I could use the square root method, or I could use this factoring on a GCF and then factoring it further. So if I isolate my x squared, I will have 36 x squared is equal to 36, divide by 36, divide by 36, and I get x squared is equal to 1. I then take the square root of both sides, and when I take the square root of both sides, I will get x is equal to plus or minus 1. Now, with those two numbers, I then have to draw a number line. So we have our negative 1 and 1, and all of our work is going to be with f double prime. So we will take our f double prime of 36x squared minus 36 and plug in a number to the left and to the right. So for example, I could plug in negative 2. When I plug in negative 2, I get 36 times negative 2 squared minus 36, which will give us a positive number. And then going through this process, I will see that I get a positive, negative, followed by a positive. Now, it's important to realize that these pluses and minuses, because we're talking about the second derivative, we have two letters, concave up and concave down. So this plus here tells us that we are concave up, this negative means we're concave down, and this positive means we're concave up. So to describe those intervals, we will have negative infinity to negative 1 for concave up, and then from 1 to infinity. For concave down, we have negative 1 to 1. We also have points of inflection, and those points of inflection happen at negative 1 and at 1, and that is due to the change in concavity. So we're changing from concave up to concave down, and then over here changing from concave down to concave up. So for our point of inflection or inflection point at negative 1, we plug into the original function, and that gives us negative 15. And then here we have 1 comma, and then plugging into the original function. But again, keep in mind that these y values, this is a point x comma y, and that y value is found from the original function plugging into the original function. So these two notations represent points, and when you are talking about concave up and concave down, this notation represents an interval. So it's representing everything from negative infinity to negative 1.